Just
All
rolling.
right. Welcome to another WorldViz webinar, our second for the day. And we're here as part of the Virtual Vision Science Society. So we're excited to see everybody. This is for our North American audience. And we'll be talking a little bit about eye tracking and studies in virtual reality, which is one of the spaces that we work in quite a bit. So let me go ahead and just introduce the speakers here. Myself, my name is Dan, and I'll be more or less the MC for this. And we've got Matthias Pusch, our CEO and co-founder of WorldViz here.
Hey, I've been doing this for many years, and this time it's virtual one more time. Hopefully next year we can drink a beer together again. Looking forward. Yeah, good seeing everybody virtually today.
We've also got Andy Beal, our other co-founder and chief scientist here, so longtime VSS attendees.
Good
And
afternoon,
then,
everyone.
go ahead, Andy. Perfect. And then we've also got Seda Rabati, who is our Vizard product manager and also the product manager for our eye tracking analytics lab, which is now called SightLab VR. And we'll be showing a little bit of that later on. So let me just go ahead and show you all the schedule for this little presentation today. So first things first, we'll do a quick introduction and just give a little bit of background on where we come from. And after that, Matthias is going to show us a little bit of some of the kind of memorable moments in VSS history in honor of our nearly 20th anniversary, I think 18th anniversary of attending VSS right now. And after that, we're going to have a really great presentation from Andy on just what the fundamentals about VR research are. So in case folks are new to the world of VR research, what are the advantages of using virtual reality as a research tool? After that, I'm going to give just a really short overview of the current kind of headsets that are available on the market in case you're interested. And, we'll save you a Google search by just going through that list real quick. And then, of course, we'll have our demonstration from Sato, who's going to show basically step-by-step how you would create a very basic eye tracking experiment using our SightLab VR eye tracking toolkit. So that's it's going to be general principles that will apply to other engines and things, but definitely will be an interesting step-by-step process, and Sato will do a pretty cool hands-on walkthrough of that. So if this is your first time joining us for a webinar, maybe you are coming to us through the Vision Science Society, we always do a question and answer round at the end. So you'll see on your little tab there that you actually have the option to ask a question of us, and we try to collect as many of those questions as we can and answer them at the very end. So stick around. At the end of the presentation, we'll be doing a live Q&A. And please, if you have any questions throughout the entire presentation, just reach out to us. Submit your question, and we'll try and get to it at the end there. So really quick, just a little background on WorldViz. We've been in the kind of what you would call business to business, but more professional virtual reality space since 2002. Andy's work actually goes back to the early 90s, and he'll talk a little bit about that. But always, and kind of from the original get-go, we were coming out of social psychology research. Some of the technology was really, prototyped at MIT and UC Santa Barbara, and that sort of focus on social psychology and research-based virtual reality applications has really been kind of the core focus of the company since its founding. Those findings and those kinds of research and development projects that we've done have also crossed over into the world of business. So we've done a lot of work in aerospace, engineering, and now more often things like marketing, training, engaging, fun things to do at conferences and things like that when there are conferences going on. So that's a lot of what we do on the business side. But for all this time, I think our real core audience has always been our academic market, and that's really what our tools are built for, is for researchers. So without any more background, I'm just going to go ahead and send out this first poll, which we like to, now that you know a little bit about us, like to know a little bit about you. How many of you are currently using VR in your research? Okay, great. Seeing some answers coming in. looks like perfect. We have a good representation of folks who are using both VR and eye tracking.
Great.
Okay, this is awesome. So let me go ahead. I think we've got 91% voted, up 94. I think we're almost there. I'll go ahead and close this out and share it, so you all can take a look and see how it went. So this is great. We've got some newcomers to the VR space, which is awesome. I think you'll really enjoy Andy's presentation, which is coming up, to kind of give a nice framework here. And then to all of those folks out there who are currently using VR with eye tracking, we'd love to hear your feedback on the tool that we'll be showing a little bit later in this presentation. So without further ado, let me go ahead and hand it over to Matthias. And Matthias, I'll pass it off to you.
Well, thanks everybody. My task is a nice one here. I'll talk a little bit about fun times and history. So we, as a company, literally go back to the first VSS in Sarasota, and I vividly remember that. We were not presenting as a company, but I was there as a researcher actually at the time. And so as a company, we have been at VSS since 2003. And so that makes it, if my counting is correct, 19 years. So that's a long time. And I just, in kind of preparation for this talk, I figured, let's just pick 3 highlights of things that happened at VSS that really made a difference. And the first highlight I want to point out is right at our first show in 2003, when we were just a small company with, I think, 6 people or something. We showed a bunch of the VR gear we are using, and we are using these kind of, you see a picture here, I would say military-grade head-mounted displays. There was only a few of them made. They were kind of expensive. At the time, I think the price point was $23,000 for a head-mounted display. And they're also not very comfortable to wear, but they were functional, same as the ones today, the consumer ones. And obviously, from a researcher's perspective, you could do things that you cannot easily do in reality. Like one of the items that we had brought to VSS was what we call video see-through, where you had an optical camera and the image was digitized in the computer, and then it was displayed in the virtual reality. So when you put on this strange-looking head-mounted display, you would still see the reality in front of you, just pixelated because you saw it through those 2 cameras, but you would even see it in stereo because you had 2 cameras, right? And you basically now, you could actually do things in reality, just like typing a keyboard, but you could do it through basically the interface of a virtual reality helmet, a video see-through, and suddenly you could manipulate anything you wanted. You could try out how, obviously, flipping the image, you can do that with a prism as well, but then other things, you could manipulate the image in any way you wanted, and you could see people's reaction to that. So on our first Vision Science conference, we showed a prototype of that, which you kind of see here, and people were like, wow, we want this as a product. So WorldViz went in and we produced commercially a video see-through device that we actually distributed all the way until, I think, 2013-14 was the last sale of the video see-through, I believe, that we made. And so it basically was a commercial product. And I would say we probably were the first company to have a commercial video see-through device that's an add-on to head-mounted displays to be available. And we were, in a way, spearheading some of the research done around that. And now, good news is, a lot of that research has led to a commercial implementation of such technologies, even for consumer HMDs. Now you have phone-type cameras, I think the rumor is that Apple has one coming out with 6 or 8 cameras or something looking forward-facing. And a lot of these cameras are used in order to create a visual image of reality for the person in the head-mounted display. That's the last Oculus Quest is doing that, and some others are doing that too now, which is a very nice way of basically allowing you to still know where you are in the space when you do a virtual reality experience. So anyway, instigated by researchers, used for research for many years, and now actually pretty much commoditized by large equipment makers, which is amazing to see. Another another piece of history here is around 2008. A whole bunch of researchers had approached us over and over again, basically said, hey, we do virtual reality, but we don't see our hands, we don't see our feet. How would it influence the behavior of a subject if they could actually see their own body? What would that do? And so we went ahead, and it was actually quite an effort to do that, but we developed a live avatar technology. That basically you could now record like tracking. Basically, you could track the body, where the wrist is or where the arm is, and you could basically then in virtual reality represent someone's body with a virtual body. And when you then look down in virtual reality, you could see a virtual representation, not just of a floating hand, but of a whole arm or of your shoulder. And you look down to see a virtual representation of your own body. And again, the vision scientist community took that. And if you punch in self-avatar, external avatar studies, you find a whole trove of research that's based partially, not exclusively, but partially on our technology. And it was great to be behind that. And I think a lot of basic research led to recognition of how to best do things. So it was certainly one of the areas where we were helping drive things forward. And then the last not least I want to talk about, and there's a little movie clip for that. In a way, the big revolution of VR happened with Oculus kicking off in 2012, and then the first prototype being available in 2013. And we got our hands on one of the very first prototypes here. And we had the technology already to make the system tetherless. So we had military-grade wireless technology that were used for other HMDs, and we were able to stick this right onto this Oculus. And this is the VSS demo night, and we were just using an Oculus Rift DK1, the very first version, one of the first prototypes, and we made it tetherless, and people were experiencing a fear of height demo. You can see how this lady is very scared. Clearly, we're telling her to step off a visual cliff, and she doesn't want to do it. And then when she steps off, she's stumbling, same as you see it with high-end HMDs. So very natural reaction. So luckily, we catch her before she jumps into a table. And so like great demo night. I think we ran 200, 300 people or something. They got their first VR experience, but also like it was really probably the first tetherless implementation of VR with the Oculus Rift. And for us, it was a proof that Oculus Rift was a valid tool for researchers to use, even though the resolution was pretty grainy at that point. The screen door effect was there. But nevertheless, for researchers, it worked for certain things, like, for example, in this case, fear of height phobia type experiments, right? And so we placed a pretty big order with Oculus, which then got Palmer lucky to come by our office a little bit later. So anyway, it's all history now, but it's good to be part of this world of virtual reality, and some of the stuff that VSS has helped us define has really been driving that segment. And we are proud and really happy to be at VSS again this year. Thanks for joining our presentation. Then I think
Awesome.
I hand over to you, and then to my colleague Andy, who is going to give a theoretical talk about VR and eye tracking and applications for research. So thanks, Andy, for jumping in here. I'm still waiting for your video here. Okay, here we go. Thanks, Andy.
Andy, I think you're still on mute.
Your audio might still be muted. Sorry about that.
Right.
Yeah.
I've got this now. Thanks. Took a few jumps. All right. Well, thanks everyone for joining us on this. Excited to be here. We, as Matthias alluded to, we've been part of this this group for a long time. It's a really great conference here, and we've been doing VR, and I've been doing it before the company back early 90s, as Matthias said. I'm going to just give a little background, kind of say what I've got listed here are some of the key elements, the key ingredients, if you will, to creating an effective virtual experience for use and research. And then I'm going to jump to a few points about what some of the, what some of the magic you get when you put all these things together, right? So first off, just a touch of history, as Matthias was doing. VR displays really come in two different flavors. There is what I have here at the top, projection-based VR. I imagine many of you have tried this. This is referred to as a cave. So it's live, real-time rendered projected images wearing stereoscopic 3D glasses that give you the sense of like being in an IMAX movie, and yet when you move around, the images update. really like a holodeck type experience, a very effective form of VR. And historically, projection really is the first forms of really synthetic imagery used for any type of virtual reality, and that was for flight simulation training. Then much more common and basically considered synonymous with VR is the headset-based, showing down there in the white headset. This is really one of the biggest marvels of VR today, this particular one. This is the Quest 2. Mobile technology, fully mobile, can be linked to a PC. Inside-out tracking that just works beautifully well. It's really doing some fantastic types of machine vision that back when this company launched in the early 2000s was still really just kind of pie in the sky to be able to do that kind of head tracking. So speaking of head tracking, no VR is really effective or possible without constantly monitoring where the user is in space and where they are looking in terms of direction. And it's when you pull in that information and you render the world, you get what's basically called object or world constancy. You get the sensation that you're now experiencing a world rather than having images that are basically glued to your head. And that is suddenly kind of the magic that people, when they first try VR, experience as presence. The technology for doing tracking today, especially in headset-based VR, is fantastic. The sensors and the integration with the graphics pipeline is such that the latency is really at or below sensory thresholds. So unless you're making a mistake on the graphics end, which is not too hard to do, you really are not going to have latency affecting even really kind of hardcore visual studies, as you all must be involved in. So turning next, binocular visual cues. These are kind of also part and parcel with VR. Very much so for projection VR. Without stereoscopic imagery running, you will not overcome the sense of flatness cues of the projection screens, and you will not have any sort of effective sense of being in a stable virtual space. With headset VR, it still can be effective, presented monoscopically, but by far the leap of the sense of having telepresence is really amplified when you allow the system to use the two independent panels in the headset and use that stereoscopic signal. Now, VR has sometimes jokingly been referred to as visual reality because that's by far the focus that most people across the board put on using VR. But really it shouldn't be. And when you combine it with really well-rendered other cues, it's an amazing experience. And within that, 3D spatialized audio is the next sort of most advanced in terms of the technology, both capture, rendering, and redisplay. Number of methods to sort of capture ambisonic or various forms of spatialized sound. But when you leave sound and you jump to the realm of touch or smell or taste, you've gone into the exotic laboratory, somewhat torture style devices. And they're fun to try, but we've got a huge leap still to make in getting those to be effective in real-time VR. The holy grail for many of us, certainly for me, is naturalistic interaction with VR. And honestly, really one of the core definitions of VR in my book is to be able to move through a space just with natural motion, walking, moving, and not doing navigation through any sort of artifacts, such as a joystick. Now, we're close. I think much of the technology is such that we're limited by the size of our spaces. And so can we run in VR? Absolutely. We actually had our previous office had a laboratory that was about 40 by 60 feet, and it was fully tracked. And we sort of set up a little track, even with little hurdles that you could jump over. And so the wireless system that Matthias was referring to was perfect for that. And we were just on the brink, and I would say we are with this technology on the brink of being able to engage people in more sport-like behavior and studying how people interact with synthetic environments. So naturalistic interaction is both, I would say, a requirement and input, and one of the results of VR. Other results are this column, and I'll start with social interaction. So those of you that have tried VR, I can't imagine anybody having not tried VR at this point, but I would say that when you first tried it, you were probably pretty wowed, assuming it was a decent VR demo. The sense of this presence of being somewhere is pretty memorable. So is your first time you experience it with a live social other, so connected to somebody, likely over distance, and having a sense of co-presence in that virtual space. This is a whole untapped area, we believe, and something that this company has worked on to a great deal. Next, ecological validity. This was one of my main motivations for getting involved in VR back in the early 90s, and that was to create a ultimate display, create a replacement to either really impoverished presentation devices like beam splitters and mirrors, or a completely uncontrolled environment. For me, I was studying human pilots and airplanes. And basically, you know, the extreme being is to put a camera behind a pilot and let them go fly down a runway and around the city, where you can't really control the stimulus whatsoever. So certainly computer graphics has helped push that boundary, but VR, when you have such complete control over creating programmatically what the stimulus is, and then still giving a sense of being in that environment and being able to interact, you really are achieving sort of an ultimate display for experimental purposes. In many ways, there is true increase in experimental power. So not only does designing environments through code allow you to reduce the variability of your studies, but also the core manipulations are more impactful. And that's just true for many reasons. The example that Matthias showed earlier of the woman walking across the plank, there, that sense of height, the fear reaction is near instantaneous and innate. And those types of manipulations are trivial often to do in VR and far surpass the other techniques, more traditional techniques used in cognitive and social psychology, where you have a subject read a passage or imagine a situation and then answer questions regarding what the behavior might be subsequently. So another motivation and capability similar to power with VR is being able to do impossible manipulations. So again, back to walking across that plank, that would be a situation that would be hazardous to do in real life without appropriate safety precautions, regardless of whether you get that approved by your IRB. But there are other situations where you might want to do a transformation that simply isn't possible. A human couldn't do. So this is just an illustration from a project at Stanford Communications Department where they were interacting with self-avatars and changing the mapping between the human limbs and the limbs that are expressed through the avatar. And it was one step towards sort of realizing a classic philosophical paper by one of the pioneers of VR, Jaron Lanier, wondering what it would be like if we had, say, 6 or 8 limbs. What would it be like to be, as his paper asked, a lobster? Last, just the data that you collect in VR is wonderful. So all the hardware there in order to be able to recreate that virtual environment is just running at really high rates. You're running at 60 to 100 hertz, grabbing where the person is, where their head is pointed, where their hands are. If they are interacting with the hand controller device, all the button responses there, as well as their relationship to everything in the visual or acoustic database. And eye tracking is one more layer on top of that. And we're going to dive into that shortly with Sato, but first we're going to get an overview by Dan on the latest hardware. Thank you.
All right, thanks, Andy. Yeah, I'll pick it up right where you left off here. I'm going to go ahead and grab the presentation. Perfect. And yeah, so exactly where Andy left off. And one thing I would add to the question about data collection is adding additional sensors to your environment. So things like motion capture, you know, biofeedback, This is stuff that we do really often with our research customers, is just adding these extra, data analytical tools and sensor collection to really fill out your subjects, a picture of how they're experiencing the stimulus. And one of the really kind of cooler things that's happening right now is actually this brand new headset that we're looking at on the screen, which is the HP Reverb Generation 2 Omnicept edition. So this is an eye tracking enabled headset, one of the second or third kind of prosumer priced headsets with eye tracking actually built in, and this is really a good solution for. We found this to be an incredibly robust system, especially with the underlying Tobii integration, and it also has some interesting things like a heart rate sensor and facial recognition cameras. So this is really kind of starting to be the more sophisticated data collection and research, but also kind of like business to business oriented VR headset. It literally came out last week, so we've been working with it, and looks like we're actually going to be delivering some in the next couple weeks here for some customers, which is really exciting. The next one up is kind of the beginning of the eye tracking revolution, effectively for folks. Before the Vive Pro Eye came out, which is what we're looking at on the screen right now, you're looking at paying $1,600, or $10,000 for a headset with eye tracking built in. Tobii licensed their technology to Vive, and they built the eye tracking directly in, and it really, for $1,600 in the United States, has made eye tracking incredibly accessible. All of these headsets that I'm showing, by the way, are kind of traditional Windows-based headsets that are running off of PCs. We'll talk a little bit about some other ones, but one more in this kind of high-end Windows PC-based headset space that we've been using a lot lately is the Star VR 1. What's interesting about this is that it actually has a 210-degree field of view. So your traditional kind of Vive system is about 110 degrees. So you're really getting an extra 100 degrees of peripheral vision there, which for many researchers is super interesting for how does this affect their understanding of a virtual environment. And it's using the same kind of Tobii eye tracking underneath, and it actually uses the Vive tracking system in terms of position and movement within the space. So those are kind of three of the ones that we've been working with quite a bit. One more to add to that would be Pupil Labs, which isn't actually a headset, but is a device, a third-party device that you can pop into an existing HMD. So this is another way of doing eye tracking. If you've already got a virtual reality headset and you need to add it to you need to add eye tracking to an existing device, Pupil Labs provides this really kind of nice option for adding it to something like a Windows mixed reality headset that might not have eye tracking built in. A few more, just kind of a quick rundown of things that are out in the market right now. The Varjo VR3 is a super high resolution option for folks who are needing extremely detailed visual environments. VRgineers is very similar to the Star VR in terms of having a very wide field of view. And then the Pico Neo 3 is actually the only Android-based system on this list so far. All three of these systems have eye tracking built in. The Pico is the only one that is running off of an onboard computer. It does not require a tether to a PC in order for you to run your environments. So that's just a really kind of brief look at the what's available right now as researchers. And compared to the cost of VR headsets with eye tracking, even 2 years ago, it's certainly more accessible than it ever has been. And almost, if you're going to be doing VR research, it almost just makes sense to add eye tracking because it's just one extra data point that you can add to your work. The one thing looking down the track, so it looks like Vive might not actually be integrating eye tracking directly into their headsets anymore, but will actually be offering a partnership for a very similar to the Pupil Labs, a little pop-in eye tracking add-on. So this is projected to be coming out Q3, which in the real world is like September. So that's looking forward to some interesting eye tracking technology coming down the track from Vive and their partner Seven and Benson there. So yeah, that's just a really quick overview. If anybody has any questions about the hardware that we're talking about here, feel free to reach out. Of course, we'll be answering all these questions at the end during our Q&A. And now that we've looked at the hardware a little bit, I'm going to give a little bit of framework for the software. So Sato is going to be providing a nice demo for us here, but just to kind of give you a structure for how we approach the problem or the challenge of creating a virtual reality experiment, and you know what we were really doing in terms of our development to create a tool that will make it easy as possible for a researcher to just get up and running with eye tracking experiments on a VR system. So the first thing is that, you know, when you're setting up a VR experiment, you're really, you know, having to code a certain amount, really setting up your experimental design and everything in maybe a game engine such as Unity or Unreal. What we've done is we've really kind of tried to compress that as much as possible into just what's called a graphical user interface, a GUI overlay. So you can see that it's very small, but there's a little picture of the menu right there. So rather than having to code, you know, a very specific hardware configuration, we actually just have a drop-down menu, so you can just pick HP Omnicept, Vive Pro Eye, whatever you're working with, and then the whole environment is just set up, ready to go with all the analytics features there. After that, what you're going to need is actually something in that virtual environment, and that's where the kind of decision delta comes. Am I working with 3D models, or am I working with you know, 360 video or immersive video type environments? 3D models are going to give you a lot more detail and a lot more flexibility, because as you can see in this little picture here, that's Sato's avatar that he made of himself. But you can see he's actually able to move around and look at this box, look at this bed, and you'll see this when Sato actually shares his screen. Whereas with the 360 video, you're really kind of working more with a rendered sphere, right? So it's like you put the camera down and it takes basically just a fishbowl around the person's head. We can actually tag objects within that fishbowl. So let's say there's a car going by in your immersive video. We have a technique for being able to tag that object, so you can do you know, area of interest tracking for stuff in a video, but it's going to be a little bit more functional in terms of navigation and interactivity. 3D models would always be the way to go for that type of setup. So we've done a lot of this in the past, a lot of talking about 3D models versus 360 video in past webinars, all of which are recorded and posted on our YouTube page. So if you have any interest in learning more about that, I'd be happy to put that a link to that in your inbox. And then the last thing I want to mention just before I hand this over to Sato is a new feature that we've built called Session Replay. So that is what's shown here. Rather than, you know, just analyzing the CSV file of you know, all the gaze intersects for your target objects or your areas of interest, we actually have the ability now to fully record an entire session of participant going through your stimulus, and actually being able to replay that and jog back and forth through the recording. You can watch the recording in a VR headset, or you can just watch it on your computer screen, and that's just giving you an extra level of after-action review possibilities for your research. And with that in mind, I'm going to hand it over to Sato so we can get a look at the technology here. So Sato, if you don't mind showing us, I'm going to hand it over to you now. All right. Perfect.
Okay, so yeah, I'm going to give you a demonstration of how you can run and analyze a VR eye tracking experiment using this software SightLab, and actually I'm using the HP Omnicept G2 Reverb edition here with the eye tracking for this demonstration. I do have to admit I'd rather be at St. Pete Beach right now, but maybe next year. So yeah, so to get started, I'm just going to show you how you can build a scene using 3D objects and 360 videos, and then configure and run the experiment, as well as analyze it with various metrics and different ways you can look at the data. And so the first thing here, I'm going to go to this tool here where you can set up your scene. So right here, I have a model that I've just opened that I got off Sketchfab. And if you're not familiar with Sketchfab, it's a great resource for getting 3D models, since they have over 150,000 Creative Commons free models that you can download and use. And so the first thing here that I'm going to check is just double check the scale and basically where a participant is going to be starting in the scene and where they're going to be facing. So the way that I'm going to do that is, actually there's an avatar here that I could just drag in that's included in the resources here in this folder. And you can see, since the avatar comes in at the origin point, this essentially is where you would start. You would be facing that direction. And you can see the scale already looks about right. If it wasn't, then you would actually move the environment, not the avatar, which would then, so if you wanted to start here, for instance, you would move or rotate the environment or scale it that way. And so the avatar is kind of just a stand-in to be able to check that everything's going to look good and you're starting in the right spot. And once I check that, I'm just going to right-click and delete that avatar. And so the next thing I'm going to do is just bring in just a couple more objects that I want to be able to collect some data on. So, I mean, if you look around this scene, you would collect eye tracking data everywhere you look. But if I want to get some more precise, like fixation data on particular objects, then I'm going to go over to that next. So I'm going to drag in guitar. And now I have that just comes in at the origin. And so I could move this just using these various like transform tools, kind of the same ones you get in most 3D modeling programs. So I'm just going to place that where I want it in the scene. Maybe add another object here. Just create. So you can see this is kind of just a drag and drop way where you can just add some objects. Any of like the standard model formats will come in. These are GLTF models mostly that you get off Sketchfab. And so now that's basically set up. And then the next step is important for us as far as tagging the objects that you're going to be collecting data on. See, there's this icon here that designates this as a group node. And the software is going to recognize anything that comes in with this group node is going to be something you're targeting for fixations and additional data. And usually when you bring an object in, it's going to have that automatically. If it doesn't, you can actually right-click and do insert above group. And then you also probably going to want to rename the object if it's something that you're not going to recognize. And then the last thing is, now these are just objects. If I wanted to collect fixation on a particular area in this scene, then I could just bring in a shape here. So I'm just calling this a fixation region, and I could scale this up to fit over wherever I want the area to be that I'm going to be collecting data on. So I could drag this with these scale tools. And it's kind of similar to what you would do like in a 360 video too, just having sort of an area that you can designate, except with the 360 video, it would be over the sphere that's showing the video. But now this is going to be also a designated area of interest, and now I can rename that. And then the last thing I need to do is just save this into the environment folder. So this right here is where you're going to save whatever environments you're going to want to run experiments on. So I'll just overwrite that. And that's basically, that's pretty much it. So this is ready to be run now in an experiment. So now the next step is I'm just going to show this same thing where I'm going to run through and collect eye tracking data on that. And then another thing I wanted to point out is I'm also connecting to a BioPack Acknowledge here. And so I have some sample EEG data. And this is going to essentially let me send markers that are going to, whenever I meet the threshold of a fixation on one of those objects, it's going to send a marker to acknowledge, and then you can synchronize that to see what the particular physiological measurement that you're measuring is going to look like at that point. So this is just some sample EEG data. And so now if I go to the main folder here, And I'm just going to run this, actually make sure the headset is on, because it might have went to sleep. So give me 1 second. I'll make sure the controllers are on. Okay. So the first thing that I'm going to do is just choose what my hardware is. So I have these various eye-track headsets. So the Vive Pro Eye, People Lab, Star VR1, the original Vive Tobii. I'm using the HP Omnicept. You can also use headsets that don't have eye tracking, like for instance the Oculus Quest. That's if it's Tether or Rift S or the original Vive or desktop mode, and that will just then use head position for the tracking. But I'm going to select the Omnicept. And now this next screen is an example of what Dan was referring to, which is the GUI-based part where you can set up some of the parameters and configure your experiment. So here's just a check mark that I could check if I want to record a video of the experiment. And I'm also going to show you an interactive replay mode that also allows you to review all the interactions and the whole experiment in a mode that you can walk around in or view in various angles. So the fixation time is just like the point that you're designating as a threshold. So this is 500 milliseconds, but you can change that with the slider. And the avatar section is when you're doing the interactive replay mode, you can choose various avatars or load your own avatars. And then the environment is where any environment that I saved in that environment folder is going to show up here. And now when I click configure, I can choose which objects I want to collect fixations on, and also if I want to like interact, say I want to grab, create in a guitar group, I can also do that with the checkbox here. And if I wanted to add an object manually, I could do that here as well. And so now I'm going to click continue, and then I enter in participant data. And so the ID is what you're going to need for saving the data files that you can access later. And so now I'm going to put on my headset, and the next thing I'm going to do is just calibrate this particular eye tracker. So get that on, and then I'm going to press the button. So I'm going to follow this point now to get a calibration. Okay, and now that that's done, I can proceed. And now when I look around, you'll see that green. Let me just maximize this window a little bit better so you can see. That green dot is essentially where I'm looking in the scene. So that's like my gaze intersect point where it's like intersecting with the 3D models. And now if I want to grab one of these objects, okay, added them to be able to grab. Right now it's just set so that they'll just float in the air, but you can also add physics. Maybe I want to grab the guitar. I'm looking at that, pretty nice guitar. And there's the bed, looking at the window. Go back over here in this arc teleport. And so you can see it's just showing in real time the fixations, and it's sending markers over to acknowledge. And now when I proceed to the ending the session, you'll just see the kind of the gaze path of where I looked around in the scene. And then next I'll show you the interactive replay mode, so I can actually close this now. And then you can see here and acknowledge that it drops markers that sends the event of when I was fixating on those objects. And so now if I run this replay, I could view this in a headset if I wanted to walk around inside of the replay, or I'm just going to choose a desktop. And there's the data file, there's the session that I ran. And so now if I play this back, you'll get to see an interactive overview with the gaze ray where I was looking, with the gaze path being drawn, and then it'll show also down here the fixations, and you could toggle these metrics on or off, or toggle the avatar on and off, the timestamp. These fixation spheres will kind of, when you look at an object that you've targeted for fixation, that'll generate a larger fixation sphere or changing color. And I could also go back and replay this or pause it and just look around from various angles. or scrub through it. I wanted to get to another point faster. Let's see, there's one question. Oh, the 3D modeling software being used by it. Oh, the 3D, I got these models mostly off Sketchfab, but I was building the scene in this particular software SightLab that uses, it's built on Vizard, so it's using Vizard's tool inspector, which comes with SightLab. And so that's the interactive replay mode. Let me go back to my slides and see where I'm at. Okay, so the next thing I wanted to show actually is that you can go now and access these data files. And so if you wanted to go, for instance, and now you have all the raw data that you can access. So this is giving you a timestamp, the XYZ position of the gaze intersect, and then this is showing pupil diameter. And then you can set custom flags here. You can also add additional things that you're tracking into this tracking data file, like maybe the hand position or other values that might be available for the different eye tracked headsets. Pupil diameter is the one that I'm showing here, which is kind of a default one. It gives you the idea of like how your pupil diameter is varying over these different parts of the experiment. And then you have this file here that shows you the different objects I designated for fixations, like how many times I viewed each object, the total view time, average view time, as well as like a timeline of when I viewed each object. And then also if you did click to record a video, then you'll have a video from a first person view that you can look at as well. And you can also, the text files can be also changed over to CSV files, which then you could look at it in like a spreadsheet editor if you wanted to do averages of pupil diameter or something like that. And now the next section I'm going to go over is just doing some 360 videos. And so with this software, you just drag your media, like a 360 image or video, into the media folder, and that's basically all you need for setting up to run this as an experiment. If you wanted to add areas of interest, then that takes a little more work, and I can go into that a little more later. But for now, I'll just show you this really quick. So I'm going to do this again in the HP Omnicept. And now this is a 360 video of, so yeah, so you could check if you want to record a video or whether you're using a video or image, or that's monoscopic or stereoscopic, and then which videos you have in that folder. So I'm choosing this one. And I'll put an ID number. Now as I put on the headset, I could actually need to look behind me where there's me over there with the portable Viz box assembling that. That's our portable VR system. So now I'm watching myself in the past in VR. And there's that 3D gaze path visualization. And now again, there's the session replay, which I could again view that in VR or desktop. And now I could look at myself, watching myself in VR. And now I could see where I started looking over here. And then since I have the designated myself and the VizBox as objects of interest in here, it'll show down in the bottom left that I'm fixating on those objects over the threshold time. And similar to the other one, I could go and toggle on and off any of these visualizations or scrub through it. And then I also get the data files as well, that's similar to the other ones where you could see the pupil diameter, which it starts out at 0 until I put it in the headset. So in the experiment data file. And with the 360 video, if you wanted to target, like I did in that with the particular part of the video, to be able to tell when someone is looking at that particular point, the way that we're doing it with the software is you just have an object like a sphere or a cube that you can place over that part of the video, basically where you see it because it's just mapped to the sphere that's in front of you. You just place the object over that part of the video, and that way you could also have the object appear at a certain time. So whenever this person, this coach, would appear in the video, you could have the object then be targeted, but the object itself would not be visible. So you're just collecting fixations, and you can have that animate along with whatever is moving in the video. You could move that object alongside that. And just really quick too, to go over some of the things you could do if you go into the code. So with the pro version of the software, you can go into the code and be able to then not only do like the areas of interest for the video, but also maybe create gaze-based interactions by having something that happens when you fixate on an object, or setting custom flags where like maybe you have an object appear and then you could set a flag to know when that happens. And also, if you have an existing Vizard script, you could just add this whole application to a Vizard script just using a few lines of code. And now I'm going to really quickly show a heat map. And yeah, feel free to ask any questions. I mean, we can get to the questions in the end and we'll try to answer them all. And so this is an example of another visualization, which is actually right now it's a separate script where you would run to have the heat map generated. And this gives you the ability to change the intensity of the heat map. And I could also view this in a headset if I wanted, since this is mapped onto a 3D scene. And then I also wanted to mention that there is a multi-user version, so you could have a collaborative session with using eye tracking. And also that you can then connect to a lot of different hardware too, so like data gloves, or like I was showing with BioPack or full motion body capture devices, and a whole lot of other types of hardware. And oh, it looks like we have the Q&A from our last session still up. So now, yeah, if you have any questions, feel free to ask them now, and I'm going to switch it back to Dan.
Peter, you have to just refresh the presentation, I think, and then the Q&A. There's just one question so far that came in. So if you get this, then
I've got it here. I can share my screen.
Yeah,
the one question we got was from about the 3D modeling tool that we use. So we use in-house 3ds Max for many of our kind of more professional projects that we're doing for customers, like because we run a small production studio in-house for creating VR content for experiments or for some commercial applications as well. But yeah, we use 3ds Max, but there's a whole bunch of places that you can get 3D assets from. Maya, as you point out, is one of them for sure. It's a really common. Blender is another one. And that's really for kind of a hardcore 3D artist who's a person who's really got the time and skills to make 3D models. If you're looking to just go and get 3D models from some out there resources, we recommend Sketchfab as one and TurboSquid as another. Those are both repositories. TurboSquid's more paid. Sketchfab's more community user generated and usually free. So
I think Fado mentioned it. Yeah, I think Fado mentioned it earlier, but Sketchfab, like Fado, you said 150,000 free. No, actually, not all of them free, but 150,000 models, right? So there's some pretty good repositories of models out there that can be used. Or these days, probably also worth mentioning, photogrammetry, right? Like these days, you can even take like something like as simple as your iPhone and do like a surround picture or something. And when you do that, you can convert it into a panorama, or with an iPhone, there's applications that allow you to take like whatever, 20 pictures or something from different perspectives, and it generates the object out of it. It's called photogrammetry. So those are new methods that didn't really exist like 4 or 5 years ago to make or to bring objects into virtuality that are actually pretty cool because a layman can do it. You don't have to be a 3D artist in order to create something. So yeah, now we get a couple more questions coming in here. I see. Yep. Oh, actually, we got a bunch more coming in here.
Yeah, adding this in real time as best I can here, Matthias. So,
well, yeah. So
do you want to take some of these? Yeah.
Well, the the timing, I mean, you could use like you could change that for milliseconds or frame rate. I mean, the actual visual like stimuli is appearing at the refresh rate of the headset, which is 90 hertz, I think, for the HP Omnicept. But you could send that data out at a higher stream. It would just be syncing it with using like a timer, which could be milliseconds. I don't know. I mean, if you have anything to add with that question, Matthias, or?
No, I think that's a good answer. I'm just looking through other questions we got here.
Yeah, and so the one about the lighting.
Yeah.
So I'm not sure if this answers your question, but we did have a customer recently that wanted to get, for instance, a baseline pupil diameter measurement. So we had just a way that the lighting would start from pitch black and just go up in different values over a certain amount of time at different levels of light. So you have complete control over the lighting in that way. So you can go from full black to full white if you are able then, if that's to be able to get a baseline measurement of pupil diameter. Or you're asking to output the environmental lighting. So yeah, you could do that as well. So whatever lighting you have added to your environment, there's an intensity value that you could output for that.
Yeah.
Pupil dilation. I mean, I guess there's pupil diameter, which would show the size of your pupils, and then I think it also depends on each headset what they output with their SDK. But
yeah, and then there is one other question that hasn't translated yet. If you do refresh, I think we'll see it. The person says, you probably said this, but are these movements of both eyes, are they gaze together or single? I think it's two gaze vectors, if I see this right? It's dual eye tracking. And do you put the eyes together in the recording? Right? So I think, Sado, you can answer that technically, but I'm pretty sure it's two rays from each eye, one, right?
It's essentially it's the distance between the two pupils, and so you have the intersect point is the value that's between the two pupils, which is creating one point, which is the intersect. So it's as if you had the two gaze rays that were, and it's basically drawing a dot between the two pupils. The way I was showing it there.
Yeah. So I think we might have roughly answered all your questions. The one thing to say is if there is any more detailed questions, like just email either sales@worldviz.com or support@worldviz.com, and we'll do what we can to answer it. We have in-house experience for I think the last 20 years as a company with all different eye trackers. So we've seen all kinds of integrations, seen all kinds of things like work and fail. Eye tracking is not trivial. It never is, because there's people like me who have glasses, and people have different shapes of heads, and there's different head-mounted displays that slip, and there's slip correction. But I have to say, and I think Sado, you can confirm that these latest, greatest consumer devices are doing a pretty good job making it as easy as possible. It's still necessary to calibrate. There will still be cases with certain glasses where it doesn't work, right? But it is actually working better than it ever did. So in terms of making it work for general people. Yeah, I think, Sado, if you want to add anything to that, but that basically is where we stand. So again, back to you, Dan. Thank you.
Yeah, I think that's it for us today, guys. This will be live on our YouTube shortly. And if you haven't had a chance to check out our YouTube channel, we've definitely got, 2020, we did a lot of webinars. So there's definitely some more to check out there. And thanks so much for attending. And we look forward to seeing your feedback in the survey. So hope you all have a great afternoon, evening, wherever you are. And thanks again for joining.
Yeah.